Great. So I'm thrilled to introduce Chris Wilde, who's here with me, who has spent the last 30 years working in and around technology and business transformation with a strong focus on application integration. He has worked over 20 countries, many, many more than me, across the telco, finance, utilities, and public sector domains. And he has an expertise in solving a very common problem: creaking legacy backends, running intertwined business processes that make any sort of business pivot almost impossible things. And I have been personally fortunate to work with Chris and learn from him on all of those years in that journey. And I believe he's the go to person for large scale enterprise architecture. So, the best person to be honest, to talk to about AI agents and integrating within an enterprise. So, let's get started straight into it, Chris. What exactly are AI agents?
That's a really good question. So let's start with what's generative AI. So generative AI is a capability that creates content. That content could be text, it could be code, it could be an image. An AI agent is just a thing that uses that capability, but within a loop. So it understands the context it's working within. It makes a decision and does the creative part. So does the creative part of generative AI. Then it observes the results of that creative thing, reframes the context, and then makes the next decision. So the key thing there is that an agent has autonomy to operate. It's not just that you are asking a question in an LLM chat box and you get a result back. The agent is running, it has agency to operate. The problems start to happen when you don't give those agents firm boundaries to operate inside. So if you've got an agent running in production and that agent's not governed, you don't have a risk. You have an issue. You just maybe don't realize you've got an issue yet. And that was the point that I started from when I was looking at building an agentic integration reference architecture. It's, can agents solve some common integration problems that I've seen in the past? And if they can, how would you govern them in production?
Very, very interesting. Only this morning, actually, I was analyzing some of the data that we are gathering, and very, very diverse set of answers that I have seen, especially to this question about what are AI agents. And your perspective is quite interesting that it's asking about agency. Today morning, actually, what I was analyzing, I saw somebody talking about not even trying to actually define AI agents, which is a very interesting perspective because depending on the domain that they are actually operating in, they can mean anything to any in that context. So, for example, if it's an insurance related agent, then the insurance domain is more important to that agent rather than the actual technical capabilities within that agent, which is something which resonates in some of the reference architecture that you've created. And so let's get a little bit of that reality check. And you've spent so many years, 30 years plus, seen billions of pounds, dollars, euros, and all the currencies trying to get enterprise systems to talk to each other,
Yeah.
whether they are ERPs, CRMs, legacy databases. Do you think AI agents are actually that universal translator that we are seem to be promised? Given the fact that, as I mentioned, that agents can mean many things to many people in so many of these domains, and or are we just building another sort of intelligent version of the same integration nightmare that we tried to solve like for the last 20, 30 years?
And this is a really good question again, because you're right. Every decade, we seem to get a new whizzy integration technology. You know, we've been through enterprise service buses and process execution engines, and then through into API-led integration, and now we've got agents coming on the scene. And what does agentic integration look like? So every iteration of that, we're getting better tooling, but I think the up until now, at least, the core problem hasn't been solved, and that is that enterprise integration requires an understanding of multiple business domains, but every integration platform is domain agnostic by design. So your
Yeah.
ESP didn't understand the domains that it was talking to. Someone needs to understand those domains, and traditionally that's been the integration architect. What's different now, though, is with an LLM, you can have an LLM, an agent, understanding the domain that it's sitting on top of. So instead of having to ask your integration architect, how does the CRM work? How do I submit an order? You can ask the CRM agent or the order management agent how it does its job. And what gets interesting is when you then have those agents talking to each other. So you can now have a natural language conversation with the CRM agent and the order agent about what are the minimum fields I need in order to create an order, and what happens when that order processing goes wrong. So you're no longer having to find an integration architect or a business architect who understands that domain. You can ask a question just like you can ask ChatGPT, and I think that's really really interesting. But the key to all of this is, and where I've seen integration platforms fail massively in the past, is the thing that's doing the orchestration. If you're not careful, you end up putting more and more business logic into that orchestrator. It's very easy to start putting a pricing rule into your workflow or whatever, and suddenly, instead of having a nicely delineated set of domains that are loosely coupled, you end up with this overarching, massively complex integration layer that knows everything about everything. So one of the concepts that I've been looking at as part of agentic integration is the concept of a strategically ignorant orchestrator. So this is a dumb AI, and I'll use the word dumb lightly because I'll come into why it's not very dumb, but
Hmm.
it actively doesn't want to know about the domains that it's sitting across. The domain knowledge stays with the domain experts, the domain AIs. The orchestrator's role is about integration patterns. It knows how to do rollback scenarios. It knows how to do branches and joins. And if you have that orchestrator agent that understands integration patterns, talking to domain agents that understand their domains, suddenly you can have some very interesting conversations about integration architecture. And that's where my reference architecture has gone. And I see that as being genuinely different to the past, where what tends to happen over time is your integration platform becomes more and more aware of the domains that it's sitting on top of, to the point where it becomes a bottleneck.
Interesting. I'll come to your reference architecture, but that opens up a very, very fascinating question for me. Is do you think does that mean that that sort of dumb orchestrator agent is a replacement of what in the past we would call that ivory tower enterprise architect?
I think you still need an integration architect, someone across
Hmm.
all of this. What happens is that architect becomes almost an approver,
Hmm.
um, in that the domain knowledge is with the domain agents, the integration knowledge is with the orchestrator, but you still need someone to go, yes, that plan looks right, or no, that's crazy. You need to be, you can't update something because you haven't searched for it first, for example. So I think the role of the architect becomes, as I say, more of um, an auditor than an ivory tower, fountain of all knowledge, because the knowledge is now readily available across the organization. Each domain agent knows the domain that it's sitting on top of.
Yeah. And one more thing which I believe will be important is not just um, that role, but the other function of taking accountability. Because ultimately, the accountability still has to sit with some human or in some human role and capacity. If something goes wrong with some of these agents, then someone has to be accountable because agents on their own necessarily cannot be held to account.
This is it, and it's a really interesting question, right? If you're putting an agent into production and that agent makes a bad decision, what do you do? So one of the things that I've been looking at is constraining that by the use of MCP as an audit boundary, but also about layered autonomy, and we can maybe come into that a bit
Yeah.
later. But the core concept of the stuff that I've been working on is, don't have an LLM execute on the primary flow of a business process. Get the LLM to design that business process, approve the design, compile it into code, run the code. Where things become interesting is if you start looking at having agents manage exception handling. So if that primary flow goes wrong, how about having layered autonomy? So for a mission critical system or a highly regulated system, the level of autonomy that an agent could have when things go wrong is maybe no autonomy. Maybe
Yeah.
maybe maybe it's all compiled, but maybe that agent could pick from a playbook. So if if you are calling an external system and that call fails, maybe the agent can have a playbook that says, okay, I'm going to back off and retry. All the way up to fully unconstrained autonomy. Maybe you've got a marketing feed and that agent could have free reign to do what it likes to fix that broken marketing feed. But the key thing is that autonomy has been explicitly granted at design time, and it's always audited. So every interaction between an agent and a back office system is audited by the MCP layer and a plugin to the MCP that handles auditing events and business events. I think you need to have something like that around your decision making process, so that you can see exactly why an agent made a decision, and you can see who approved the fact that that agent could make that decision.
Fabulous, fabulous. So I have your reference architecture right in front of me. And you, like you just mentioned, argue for this domain led agentic integration architecture, where it's not so much about just connecting, system endpoints, but about having agency within the agents as well as expertise in their respective domain. However, if I translate that into, the practical challenges that we've seen in the past, would it be fair to say that there is still a glass ceiling of AI adoption in the company? Because it's not so much about the smartness from the LLMs and the natural language processing that you just mentioned within the agents,
Mm-hmm.
but rather the readiness of the company's internal domain and data layers themselves. Because ultimately, the knowledge and expertise lies within that domain and data layers. So, the agents, how will they get actually trained so that they are well adopted?
Yeah. I once had a program manager who was worried about technology decisions. And I told him not to worry about the technology because I could deliver him a failed project no matter which technology we chose. Because it's never about the technology, it's always about the business readiness, the people, and the processes. And this is exactly the same with agents and agentic integration. But that doesn't mean that you have to go on a 2 year sort of data discovery and process mining effort before you can deploy your first agent into production. What I'd recommend is, you start small, pick a domain, and build out the landscape incrementally. So imagine you have a CRM platform and you deploy a CRM agent in front of that platform. It's already got a good amount of information and domain knowledge just through MCP tool discovery. So it understands what its processes are, what the data types, the data structures it has. You don't need to have done a massive data mining exercise in order to get that. Now think about building on that. So now you've no longer got the domain knowledge inside the CRM business architect. The CRM domain agent knows about that. Now build it out. Go for the next one. Think about order management or product catalog or billing or whatever. Build them incrementally. Get your data structures right, but take the bounded context approach. Right. Get your data structures right within that domain. Don't worry about or don't try to get your data right across the entire enterprise because you'll fail if you try to do that. MCP is really interesting because you can use the MCP boundary to tidy up some of that mess. So keep the messiness inside that MCP wrapper, provide clean interfaces to the agent to use. But I think the key thing is get your bounded context right and build your agents on top of those bounded contexts. Don't try and boil the ocean. Don't try and describe every single business process in your organization. I think if you do that, you'll have success.
Yeah, I absolutely agree. In fact, I have seen one of the organizations where they kept saying, "Oh, we need the data dependency right," and they got into a massive investment, the data lake problem, right?
Yeah.
That we need to build this data lake before we can even think of the AI use cases, rather than thinking of the other way around. That let's look at what can actually deliver value now and early, and start building that, and then finding that, discovering that data, and taking it further. And those are the approaches which I'm seeing again in the research as well, which are showing success, early success, rather than being stuck in that doom loop of proof of concepts or in the doom loop of discussions on data and data dependencies, etc.
And think about where you're handing off between those domains. It's perfectly valid for a CRM's view of a customer to be completely different to a billing system's view of a customer.
Yeah.
What you need to get right is how you cross the data across the boundaries. So get the contract right between the billing system and the CRM system for each interaction. Get the domain agents understanding that. Document those specific data types keep them as primitive as possible. You don't need to have an enterprise wide canonical data model. Your agents just need to know how to talk to each other.
Yeah, and this is where, as you mentioned, some of the reference architecture patterns that you've developed actually could be useful in developing some of those solutions basically, so that there's better adoption. Now, of course, with all opportunities come risks. Basically, AI agents present lots of opportunities.
Mhm.
We discussed the challenges around not understanding of context, or not having the expertise, or not having accountability, because AI agents cannot have accountability, at least at this stage. We don't know if there's going to be a matrix world in the future. uh, but then, especially in regulated industries where you've spent a lot of time as well,
Yeah.
such loose integration could be a big security risk, reputation risk. So, how does the prompt layered architecture that you just recommend in your reference architecture allow a manager to give the agent keys to the kingdom, but still without the compliance team having a big, massive heart attack? You know, right?
Yeah, yeah.
We've seen those.
So the short answer is don't give your agents the keys to the kingdom.
Okay.
The second you allow an agent to make a decision in production, you've got a governance gap. And the
Mhm.
question is, how do you bridge that gap? And the reference architecture I've come up with bridges that gap in three ways. So the first thing is deterministic code. Your LLM is used to design systems to create deterministic code. So in my integration platform, it creates a workflow, an integration workflow. Don't have an LLM on the hot path making decisions if you can avoid it. And if you can't avoid it, be very clear on the scope of the decisions that LLM can make. So another concept that I brought into my architecture is the concept of layered autonomy. As I say, I use this in particular for exception handling. So the primary flow is always deterministic. If something goes wrong, you can decide the level of determinism, the level of autonomy on an exception by exception or flow by flow basis. So say you're creating an order and that order goes wrong, you could set up the management of the exceptions around that order to be fully deterministic, so no agent involved, or maybe constrained autonomy. So there's a playbook that the agent can pick from, but it's only allowed to pick from one of those playbook entries. It can't go off piste. All the way up to agent assistant but human decision. So the agent makes a choice of what to do next, but it has to be approved by a person. So there's an approval workflow there. All the way up to full autonomy, where an agent can do whatever it likes to fix this problem. Um, but by declaring the level of autonomy for each exceptional step for each flow, you've always got that audit trail. And then you need to be able to audit every action that an agent takes as well as that. So I'm using MCP as the audit boundary. So as well as having agents communicate with their back office systems by MCP, my compiled workflows also use MCP as the gateway into their systems. So that's a bit of an odd concept. So I've got deterministic workflow code calling an MCP server to update a CRM platform, for example. The reason why I'm doing that is because MCP then becomes the audit boundary. You can plug in audit logging and business event management into the MCP layer. So every time you call an MCP tool, there's an audit event fired that says this tool was called. If a business system is mutated, there's a business event fired out of the MCP system that says, this customer was created. So having a single audit surface and logging surface gives you the ability to run an agent in production under a level of understood autonomy, but also have a full audit trail from the step in the workflow all the way through to the decision that the agent made. I think you need something like that, particularly in regulated environments. You need to get that right. And as I say, the way I'm doing it is by that three-layered approach.
Fascinating, fascinating. In fact, I think it's so relevant that I'll share with you one of the papers that we conceptualized on personal AI agents. And one of the big design attributes over there was this delegated authority and autonomy. And your approach on having these layers of autonomy can be very, very applicable for service providers who are designing such personal AI agents. So this
Yeah.
has been very, very, not just, of course, it's relevant absolutely to the enterprise because it's an absolute need over here. But in the space of personal AI agents, as you know, it's almost left to wide open. It's almost controlled by the service providers. So
Yeah.
what we have recommended is there has to be a little bit of an inversion of control towards the consumers, especially in vulnerable situations and contexts. They need to have a bit more control than just the preferences which the service providers provide, and which could have unintended consequences. So some of the reference architectures I think are definitely applicable to that research as well, to take it forward to see how that design can actually be materialized in actual production environment. So this has been a fascinating and incredibly insightful decision. Thank you so much for your time. You've painted a great picture to understand, the key to agent adoption, and how integration will be actually that key, and how agents themselves will help navigate that integration challenge.
Yeah.
So very, very interesting conversation. Thank you so much, Chris.